Line on for a second. We've been talking about solutions and suspensions and colloids and mixtures of all kinds. And today, I want to start talking a little bit more specifically about concentration of these guys. Okay, so up till now we've had mostly questions, or mostly notes, a lot of demonstrations to go along with them. But it's going to be different now for the next few days because I'm going to learn about concentration, which means I'm going to be using numbers. I'm going to be doing calculations because it's not enough to just mix two things together. When you guys are using chemicals back there, they're not just randomly thrown together. When you get a shot at the doctor's office, you don't just get, the doctor's going to say, oh, give him a lot of morphine, give him a lot, give him a concentrate, give him a bunch of it. He's got to say specifically how much based on how much you weigh, and you got to know how much to get. Now, there's a lot of different ways we can measure concentration, and it's kind of important. We have very accurate ways to measure. The first one I'm going to talk about is actually one of the least useful for chemistry, but it's used a lot in biology. It's used a lot in nursing. You probably even have it written on a lot of your medicines or even saline solutions for your eye contact lenses, and that's percent solution. Okay, turn that light off for me. Let's talk about how to do a percent solution. Okay, there's several ways I'm going to calculate concentration. Percent is probably, again, one of the least useful ones for actual chemistry, but probably used the most in your life. And the nice part about percent solution is you can actually tell me how to do it. Because we have done percentages a bunch of times. Where have we seen percentages before? What have I used as an analogy for percentages in a class? How would you get the percentage of girls in the class? What I heard generic formula. Part over the whole times 100, right? Number of girls over the whole number in the class times by 100, right? It's the generic. And by the way, is that the only place we've seen it? No, we saw it with percent error back in chapter 1. We saw percent composition on the periodic table. Remember percent composition of sodium chloride, mass of sodium over mass of sodium chloride, molar mass. We saw it. Where else? Percent error, percent composition. Well, now we're seeing percent solution. I thought there was one other place we saw it too. What do you think I'm going to do? Or you tell me the formula for percent solution. What's percent solution going to equal? Part over the whole times 100 is what when you're talking about a solution? What over what? What's the part? What's the part? The solute. So the mass of the solute over the mass of the solution times 100. That's exactly right. Mass of the solute over the mass of the solution times 100. Now, that's not necessarily what you might think when we go to do the problem, as you see in a second. That's the end of the notes. Like I said, this is going to be totally different than what we've been doing for the past week or so. Past week or so, I've been giving you a lot of notes and doing a lot of little demos. I don't have very much on the demo front here, a little bit. But I do have a lot of problems to do and not very many notes. Okay, that's the end of the notes. That's your formula. Let's do this example. See if you can do this one with me. And let me point out to you the mistake I see most commonly at this point. What will people do at this point that is a mistake? What might you want to do this problem? Well, let's write the equation down. Let's see. Percent solution is going to equal, the part over the whole, the mass of the solute over the mass of the solution times 100%. Okay. What's my obvious mass of the solute? It tells it to you right there. Everybody agree it's 5.0 grams? And what are we going to divide that by? Right. Some people want to put and will put as a mistake 25. What does it say about 25? 25 grams of water. Yeah, that's the thing. It doesn't specifically say it's a solvent, but it is. Let me show you. All right, say for example, if I have turn that light on for a second. If I've got my beaker and I put 20 grams of water, which would be about 20 milliliters of water, so about that much. And if I have 5 grams of my salt in here, okay, you got to remember. And by the way, I'm doing this for a reason. It's not just for this. When we go to the one we're going to do on molarity in a next period, second half of this class, you're going to see there's a difference. There's a reason why we don't do percent solutions very often. When I put these two guys together, if I put them on a scale now, it doesn't weigh. Oh, by the way, it should be 25 there, shouldn't it? All right, put 20. Here we go. It's not 25, right? It was 25 of water, but I just added 5 grams of salt to it. Now, if I put it on a scale, how much is it going to weigh? 30. So don't forget to do that. Don't forget to divide by the mass of the solution. Get that light off for me? So I basically have to divide by 30. I'm adding these two guys together. Okay? And that's one thing that people do wrong. There's something else we'll see in a little bit. All right, times that by 100. Do that on your calculator. What do you get? Anybody?
1.6.
What's the? Yeah, okay, that's good. You know what? I'm going to say that's good, right? I'm going to say that's fine. That's a fine answer.
Awesome.
What's the answer? Anyone? Ben?
17%.
Did anybody else get 17%? Everybody get 17%? You don't really get that on the calculator. What do you get?
16.6.
Okay, so 17% because significant figures, he only has 2, and I've got to keep significant figures. If I just put 1/6, it doesn't help me. I have to have significant figures. All right, good enough. Well, let's take a look at this next example. Okay, watch. Because I obviously can ask it multiple ways. This is asking you how to prepare the solution. You just saw me prepare it. I took 25 grams of water, and I added 5 grams of salt to it. What if I gave you the percent solution and asked you for how much sugar I would need to put in it? In other words, I want to make a 5% solution, and I want to know how to make it, how much sugar I'm going to need to make that. This is really a very easy problem. It doesn't really require any chemistry. It's just a common sense understanding of percentages, which I know you guys have. I know you can do. You know what to do to get a percentage of something. Everybody's done it at some time or another. If there are 24 kids in this class, what's 50% of that? 12. See, you know how to do it. If you're leaving a tip at a restaurant and you're really cheap and you want to leave a 10% tip, you just leave 10% of the chips that you're eating, you leave them behind. 10% tip. You want to leave a 10% tip. Your bill was $30. What are you going to leave? 3. By the way, to leave 15%, it's an easy way to do that, right? 3, 30, right? 3. And then you take half of that. What's half of 3?
1.5.
Yeah, 1.5. So you leave 4.5 or $4.50 for your 15% tip. See? You take the 10%, which is easy to get. But in all these cases, what are you doing to get a percentage? You're multiplying by the percentage with the decimal place moved 2 spaces, right? That's what you're basically doing. Because that means 5 over 100. That's what 5% means. 5 out of 100 times, okay? All right. So what will I do in this problem to solve it? This is not a chemistry problem. It's very simple. Understanding percentage. What am I going to do here? Josh.
Multiply 150
Mm-hmm.
by like 0.005.
Not 0.005. Good mistake, though. People want to just put 2 zeros. I didn't say 2 zeros. Move 2 decimal places. 0.050 times 150 grams will give you, do the calculation on your calculator, what do you get? That's all you have to do in this problem. What do you get?
7.5.
So this tells you this, guys. By the way, there's a lot of ways I ask this question. I'm going to ask it in the lab on Friday. I'll say, make up a 5% solution. you'll have to know to add 7.5 grams of the salt or sugar or whatever I'm having you make into 150 grams of water. By the way, you are going to have to do this. You're going to have to do it in that lab. You're going to make one solution here, another solution there, and then you're going to mix the two together to see if you get a precipitate. Okay? Like we've done, we've been predicting those precipitates for the past couple of days too. So we're going to put it all together into a lab on Friday, which means you'll be confused. Because whenever we put everything together, you get confused. All right, let's try one more of these. Actually, there'll be two more.
That's so true, that one.
It is. Okay, let's try this one here. In that same example, if I asked you how much water you would need, the answer is not 150 grams. What's the answer going to be? How much water would you add to your 7.5 grams of salt? What do you think you're going to have to do here? Ben.
142.5.
Okay. You're going to have to take 150 grams minus the 7.5 grams you already have for the salt, and that will give you 142.5 grams. Is that correct? Of water. Now let me stop you there because, again, hinting ahead to the lab on Friday. Some of you are going to say, so I got to put a beaker on the scale and add water to it till it goes up to 142 grams? Do you? Why don't I have to measure on a scale my 142.5 grams of water? What can I do that would be a lot simpler, Garrett?
Just put it up to 142.5 milliliters.
Yes, I would just use 142.5 milliliters. You don't do that on your paper. I didn't ask that. I'm just saying, for the lab on Friday, since the density of water at the temperature in this room right now is about pretty much 1 gram per milliliter. If you need 142 grams of water, you need 142 milliliters of water. They're the same thing. Okay? All right? So that will be nice. You'll simply add, if I ask, this is the question I asked you in the first procedure, you'll take 7.5 grams of sugar and add it to 142.5 grams of water. Okay, it won't be the question I ask you. I'm going to ask you for guys that I could add together and get a precipitate, but just saying. All right, last example. I want someone to look at this guy. Oh, that should be a 25 up there, sorry. Well, that won't change. Just copy the way it is. Copy the way it is. Because you're going to see this in the worksheet I'm going to give you in a minute. You're going to have a worksheet to do first, and then you're going to have the homework you can work on when you're done with the worksheet. Copy that guy down. This problem, you may say, well, we've already done one like this. Look at how it's worded. This time when I go to do, watch, I want you all to see this now. When I go to do this one, percent is going to equal the mass of the solute over the solution times 100, right? What's the mass of the solute? We just had a problem like this, 5.0 grams. What's the mass of the solution? Bo?
25.
No.
20.
That's exactly why I'm doing this one. In the previous problem, if you read this question, it's virtually the exact same question with the exception that it says 20 grams of water, 25 grams of water, in which case you had to then add the two together. This guy says 20 grams of solution. Be careful how it's worded. You're going to divide that guy by 20 grams. See what I'm saying? I'm telling you, I already took into account the fact that the water and the sugar are together. That's the mass of the whole solution times by 100. In this case, you get what? How much? 25%? Right? 25%. That look good? All right, so in the worksheet you're about to get, this worksheet right here, watch how it's worded. If it's worded solution, you do not add the 20 and the 5. All right? It won't be 25. It'll be other numbers anyway. Okay?